So that's my dry vent size. Here's my dry vent, and it is and does not remain less than 1.25 inches. We can use an 1.25 inch dry vent. Isn't it easy? It's like a puzzle, isn't it? Once you see it and apply the table and understand drainage fixture units, it's like a game, right? How do I complete the game? How do I piece the puzzle together? And that's what it's all about. All right. All right. See how we're fixed for time. I want to clear up something. Good. I have enough time. Fantastic. I'm going to advance. Let me get the workbook here. Bear with me a minute here. I have a method to my madness, I think. All right. Let me look at this. I want to go to the utility finish section here. Now, by all means, take this workbook and read through it. It'll really help you a lot when you're going through this with the code. And if your aspiration is to be a plumbing inspector or plumbing plans examiner, this is a really good tool for you to use in your everyday application in your building department. So I'll hit on some of this stuff tomorrow in the mechanical. Some of this stuff is the same. So I want to get to the utility section. Let's see. Oh, that's bathroom. Yeah, and read through the rest of these finals here. It gives you specific dimensions, specific criteria on showers, toilets, things of that nature. It's real easy reading. I need to get to the utility. Ah, here it is. Great. What I'm after is this section right here. Okay. Yep, this section right here. So we're going to talk about the last section here, the water heater inspection. Okay. So if you have your booklet, turn to this page here.
What page number is that?
253 is what it says to me. You got 253 pages? My gosh, it's like a book. All right, now let me advance my slide. Bear with me a minute here. Get to the right location here.
253, huh?
Yeah, it's right here. It's task 4, which is the water heater inspection. All right, let me get my slide up to par here, and then I'll discuss. Okay, here we go. Water heater inspection. Boom. There we go. All right, so I think I'm all coordinated here. Here we are. Here we are. Specifically, we're talking about water heater inspections, okay? And as we saw this morning, you know that we have chapter 28 that helps us understand water heater requirements, okay? There's also a section in chapter 24 as well for gas water heaters, some of the listing requirements, specifics on that. Now, with water heaters, what you have to understand, the storage type that we're going to be talking about here is, you know, when we heat up water, we have a volume expansion, we have a temperature increase, and we have some safety controls that must be addressed. Take a look at this here. Right here, I have a water heater, a graphic of 2 water heaters down at the bottom right-hand side. With respect to these 2 type water heaters, they're both exactly the same. But what we're looking at is we're looking at the safety valve here. It's called the temperature pressure relief valve. A lot of these things are called combination because they work for both pressure and temperature, okay? Temperature is what we're looking at, 210 degrees Fahrenheit, that valve will open, right? Pressure is 150 PSI. That valve will open. So this is a safety valve. We do not want that valve to just blow out horizontally. We want to have a pipe, ladies and gentlemen, a discharge pipe indicated and installed according to this section. I'm in chapter 28 here, 2804.6.1. Here's your requirements for this pipe here that has to be connected to this safety valve here. So this pipe is basically indicated right here with the requirements. The pipe shall not be directly connected to the drainage system. Understand, we got a high temperature, high pressure here. If that thing goes off, we have no idea what the drainage material is, if it would accommodate it. Number two, the pipe needs to discharge through an air gap located in the same room as the water heater. You know what an air gap is, don't you? Not an air break, an air gap. Remember that from this morning? That's where we have atmospheric open space between the receptor or the floor to the discharge pipe. The pipe cannot be smaller than the diameter of the outlet of the valve served, right? And discharge full size to the air gap. So in other words, if this is a 3/4 inch pipe outlet on the safety valve, that pipe has to be at least 3/4 of an inch, right? Serve a single relief valve, right? It's got to serve a single relief valve. You can't gang up these relief valves like I'll put one pipe in for 2 relief valves. That ain't going to happen. Each relief valve gets a separate discharge pipe. It's got to discharge to the floor or to the pan serving the water heater or storage tank, to a waste receptor or the outdoors. Now, sometimes we have water heaters that are located up on a second floor, right? Maybe it's a second floor laundry area, in which condition, you know, you're probably going to need a pan underneath the water heater, because if it ever leaks, these storage type water heaters, it's going to cause damage to the construction or the finishes. You put a pan underneath it. Here's your pan requirements that's given to you in chapter 28, either galvanized or plastic, things of that nature. We'll put a pan underneath here. And as you can see, this pipe is permitted to discharge in the pan, right? See right here, to the floor or to the pan serving the water heater, either one. Number 6, discharge in a manner that does not cause personal injury or structural damage. Case in point, look at this. This will cause personal injury. If I just put a little piece of pipe horizontally, that ain't gonna work. It's gotta be piped down to the floor of the pan. Number 7, discharge to a termination point that is readily observable by the building occupants. If you discharge this outside, then it's got to be at least readily observable. What does that mean? It really doesn't say, does it? But maybe what would help, at least in my opinion, is provide some kind of a label on it, you know, readily observable. Put that this is the discharge from the water heater. You can't trap this pipe, item number 8. Must be installed to flow by gravity. There can't be any pump hooked up to this thing, or you can't put it in a sump pump or a condensate pump. Got to be by gravity. It's got to terminate not more than 6 inches and not less than 2 times the discharge pipe diameter above the floor or waste receptor. So basically, if this was, I don't know, like 1 inch pipe, let's say, 6 inches, right? But not less than 2 inches or 2 times the diameter of the pipe, right? So it's 2 inches to 6 inches. That would be the minimum and maximum. We can't have any threaded ends on the pipe either. No T's, no valves, things of that nature. It's got to be constructed of materials that are indicated as tested and rated, you know, for the temperature, mostly in this section here. See that 2906.5? We'll understand some materials there. You see this last one here? This was recently added in the code here, this very last number 14. And it's basically telling us that when we have like PEX or polyethylene raised temperature, that's what PERT is right here. Basically, we need 1 nominal size larger, okay? So if this is 3/4 of an inch, right, and I use a fitting, right, to come off of here, I need to increase that to not 3/4. I need to increase that to 1 inch PEX pipe or polyethylene raised temperature because of the tubing sizes. The tubing sizes is a little bit smaller than the nominal pipe sizes, ladies and gentlemen. That's why this was put in here, so we can at least get the close to the full opening of that valve when it discharges. Okay, that's a brand new section that was recently put in the code, item number 14. All right, so do you agree with me that if I had a water heater, call it a gas water heater, right? And I had a malfunction, or maybe somebody put a plug in the temperature and pressure relief valve, what would happen if that aquastat remained open and it kept heating up the water in this vessel?
Explode. Boom.
Somebody
Build the
said
pressure
boom.
up.
Is that what I heard? Boom?
Explode.
Yeah, you remember those two crazy guys that used to be on TV? The what were they called? I can't remember. I don't know. They did all kinds of
Mythbusters.
wild experiments. What was that?
Mythbusters.
The Mythbusters. Yeah, they actually did that to a water heater, and I have a picture here to show you what happened to that thing. Write these code sections down, plumbing inspectors. You get this in chapter 28. This is your technical stuff. Pressure relief valve, here it is. Maximum of 150 PSI, that's the rating. The rating of the temperature relief valve is 210. But guess what? We could have a combination temperature pressure relief valve, which we normally do in one valve assembly that gives us both pressure and temperature safety accordingly. All right. When you go and do your plumbing inspection, you always check the safety valve. It'll indicate the pressure setting, the temperature setting on that particular valve. Okay. Now, what I want to do, because I want to end up like right here, is I want to bring in my workbook that you have in hand or on your computer, and I want to show you something. Okay, so understand that when you heat up water, you know, and if you have a malfunction in your safety valve, your temperature pressure relief valve, or somebody just forgets to kind of hook it up, maybe puts a plug in it or a nipple in a cap, what are you actually doing? I wanted to show you a comparison here. Take a look at this here. It says energies developed in a 30-gallon hot water tank. What I want to show you is when you have water that actually turns into steam, ladies and gentlemen, at a pressure of 50 PSI, water will boil at almost 300 degrees Fahrenheit. Guess what it does? It gives you a huge amount of energy in foot-pounds, right? Look at how much energy it gives you. Almost a little over 2 million foot-pounds of energy. That's a huge amount of energy. That compares to nitroglycerin, a pound of nitroglycerin, as far as the same energy value. So it goes to show you that, you know, sometimes we have some severe things that happen when we have malfunctions, such as these water heaters that maybe should have been inspected. Maybe somebody didn't catch the plug into the temperature pressure relief valve. You know, sometimes, you know, homeowners and things of that nature, sometimes these things leak, right? Sometimes they leak, right? And God forbid if somebody ever plugs this thing up, you know, that would be quite a dangerous proposition. Just wanted to show you this chart. You have it in your book. Keep that in mind. And I don't have that picture, but those Mythbuster guys, you know what they did? They actually heated up a water heater in a building, like a 2-story structure that they built. And they heated this thing up with a propane line, I guess. And they kept on heating it and heating it. And they blocked off that temperature pressure relief valve. You should have seen this thing blow. I'm telling you what, the amount of steam, the superheated, built up energy in this vessel, it blew all the way through the floor and the roof. And man, that thing went a couple hundred feet up into the air. I mean, it's a projectile. So it just goes to show you, don't take your plumbing inspection career lightly, because you could catch something out there that could save a person's life, you know, moral of the story. So this is where I want to end it. I'll open it up for any questions, comments. Did you learn anything today about plumbing? Was it okay or boring or things of that nature? What do you think?
I got a quick one, Jerry.
Yeah, go ahead, Don.
In the state of Washington, we unfortunately have the UPC.
Okay.
And I'm just going through the slides here. I noticed that apparently you folks authorize a high loop on a air gap situation for a dishwasher. Is that true? Terrible question for you, right? Of course it's true. It's in the slides, right?
It is.
All right, because UPC doesn't allow it. That's why.
Yeah, I know.
Yeah.
I
Gotcha.
teach the UPC, and there's a few subtle differences. Yeah.
Got it. All right. I just wanted to verify.
Good comment, Don. Yeah. All right. So, well, I hope everybody enjoyed the class today. You know, like I say, take a look at that workbook. Plenty of great information. Question?
Sorry. Are there any like practice tests or questions for plumbing?
There is. If you go to the ICC site, go to training and education, and it's somewhere over there that you can actually find some question. They're test-based questions that you can purchase for your plumbing exam, and it would be the P1 examination. So yes, there are questions available.
It's called, there's actually, Jerry, there's a book for you to practice. There is a book with questions so you can practice on that too.
Ah, okay, great. Yeah, there's all kinds of information out there, Roshana, that you can utilize to prepare for your exam.
Thank you.
Yes.
Rishwana, there's also illustrated manuals out there that are super helpful if some of the products you're not super oriented with as well. Jerry, awesome presentation.
Thank you so much.
Thank you.
Watched many over the last 30 years, and it's always awesome to listen to someone who's enthusiastic about what they do. So thank you for that.
You're welcome. Thank you. And great. So tomorrow we're going to be talking about mechanical systems. It'll be a good class tomorrow. We're going to be talking about not only air distribution, but exhaust. We'll talk about gas piping. I have some more examples of gas piping design installation. It's going to be a good class tomorrow. So hopefully everybody will join, and we'll have fun again tomorrow. Okay. Any other questions before we leave?
Good.
Oh, thank you, Jerry. See you tomorrow.
Thanks,
Yeah.
Don.
Everyone tomorrow. Have a good night, everybody.
Thank you, Jerry.
Great. Thanks, everybody.
Thank you, Jerry.
Thank
We'll
you.
see you
Have a good
tomorrow.
one.